Hello everyone, this is Prateek from TechStop, and today in this video we'll be going through transfer queue in Java. So we'll see how transfer queue is implemented in Java, and so I'll be showing you two ways through which we can use transfer queue, and uh, uh, and we'll see the two type of implementations how we can use transfer queue. So let's get started. So this is the agenda for this video. So I'll be introducing you to the transfer queue and what is its implementation, and also will be showing you the code examples of how to implement transfer queue. So firstly, the introduction. So the transfer queue is a type of blocking queue which is used in the consumer producer scenario, wherein consumer has to wait for the producer to produce something and share it via queue. So it's basically a queue via which a particular consumer can transfer the messages to the producer can transfer the messages to the consumer, and it's like a blocking queue wherein a producer will be producing the messages, and in some scenarios it will get blocked till the time a consumer is available to consume that particular message. And the definition of blocking queue would be a queue that additionally supports operations that wait for the queue to become non-empty when retrieving an element and wait for the space to become available in the queue and storing an element. So if you understand from this definition which I've taken from the Java doc, it says that the queue so some of the processes will wait for queue to become empty so that they can put some messages onto the queue, and the producer will wait for some space to be available in the queue so that they can put some messages onto the queue, and some consumers would also wait for the messages to appear in the queue if the queue is empty. So this is how the blocking queue works. So the transfer queue in Java, it's an interface, and link transfer queue is one of the implementation. So it's an unbounded transfer queue based on link nodes. So it doesn't have any bounded spaces which is allocated to the queue, and it's based on the link nodes. So let's switch to the IDE so that I can show you how we can implement transfer queue in Java. So here I have a code where I have implemented a Java project, and a class is there, the transfer queue demo, and it has a static transfer queue object, and while initializing the application, this transfer queue demo application, I've initialized this queue with the link transfer queue, which is an implementation of this interface transfer queue. And what I'll be showing you is the two examples. First is where there will be a single producer and there will be multiple consumer application for the example, and other will be the drain consumer example. So I'll explain how it works. So firstly, let's go through the single producer and multiple consumer example. So we have a producer class. Let me open it. So it's a class which implements runnable so that I can run it via thread, and it has a counter static variable, and just a producer name, so that I can provide I can give a name to the producer while initializing the producer object. So while initializing it via constructor, I'll be giving it a name, and then in the run method, which will be overriding as it implements the runnable interface. So it refers to the same link transfer queue which we have initialized in our transfer queue demo application. And what it does is, so it runs an infinite loop, and every time in every iteration it creates a message, and by incrementing a counter so that we can have messages with the different name, and what we do is we try to transfer the messages to a particular consumer, to the consumer, whichever is available. So for that we have a function called try transfer. So let me switch to the documentation. So what does it say is that try transfer transfers the element to a waiting consumer immediately if possible. Okay. So and there is also a timeout, a different version of try transfer, where transfers the element to a consumer if it is possible to do so before the timeout elapses. So I think this is what we have used, like trying to transfer the message to a consumer, whichever is available, to get the message from the queue. And there's a timeout being set as 2 seconds. So it wait for 2 seconds to transfer the messages to the queue, and it will return a boolean variable signifying whether the transfer was successful or not. So it will be set to true if the transfer is successful, and so if true says if successful, or false if the specified waiting time lapses before completion, in which case the element is not left in queue. So it's like if it is able to transfer it to a particular consumer, to any consumer whichever is available, so it will return as true, and if it is not able to transfer within this time frame, then this function call will return false. So what we'll do is we'll check the outcome of this function call. So we'll check whether we are able to successfully transfer to any of the available consumer. If not, what we'll do is we'll wait for the consumers. So it will wait that it will keep on looking for the consumers. So it will keep on checking in every 3 seconds, just for the demonstration purpose. So it will keep on checking every 3 seconds that if the queue has any waiting consumers available. So if it has, then it will come out of this loop and it will start producing again. Okay. Or else, if say the consumer it was available, so the previous transfer was successful, then just for simulating the delay in producing the messages, I put a sleep here for 1 second, so that after 1 second it will start transferring the messages again to the consumer. So this has waiting consumer, I'll show you from the definition, the documentation as well. So has waiting consumer, it returns true if there is at least one consumer waiting to receive an element via blocking queue.take or time. So this is the definition of that has waiting consumer. So this was the producer which I've coded. Let's move to the next part. So what we do is we initialize a producer with the name producer_1, and we create a thread out of this runnable implementation, and we start the thread. Then we have a consumer consumer class which I have coded. So it also implements runnable interface, and it also has a name associated with it, and it also references the same link transfer queue which we have initialized in the transfer queue demo. And what we do is we try to get the message from the queue. So it's a call to the take method. So what it does is, let me switch to the documentation. So it's part of the blocking queue, because the transfer queue implements the blocking queue. So in the blocking queue, we can see the take method, and which says that retrieves and removes the head of this queue, waiting if necessary until an element becomes available. So it's a blocking call to get the message from the queue. So unless the message is available, it will wait for the message to arrive on the queue, and once it arrives, it will read the message. And just for demonstration purpose, I've kept a I've kept a sleep of 5 seconds so that to demonstrate the delay in processing any messages. So that was the consumer class, and then we start the thread, and we create a thread and we start it. So I've coded two consumers just to demonstrate there are two consumer applications consuming from the same queue. So let's start it and see what happens. So I'll just stop it because it will keep on running. So if you see here, what we can see in the logs is, so we have initialized the consumer one. It tries to get the message from the queue, so it blocks itself to get the message because there is no message available as of now. So then we have a producer thread which starts and it tries to transfer this test message underscore one, and then we have consumer 2 as well, which is also trying to get the message from the queue. So since there were consumer applications which were available, consumer threads which were available at the moment the producer was trying to transfer any message, so the transfer result was successful. So this is being printed from this part. So the transfer result was true in this case, and so I printed as successful. So then consumer one picked up that message, and the test message underscore one was read by the consumer one. Then again producer one tries to transfer the different message, test message underscore two. So this time consumer two read the message and printed the same. So this way the producer will keep on producing the message until the consumer will be available to consume those messages. But once the consumer applications goes into sleep, or if they are not available, then the transfer result would be failed in that case, and it will go into a waiting loop where it will wait for the consumers to come back and start polling on the queue. So it will wait for the consumers. So then both the consumers come out of the sleep and they start polling on the queue. So this at this moment producer one will detect that there are consumers which are available now, so it will start producing again. So this time it produces the test message underscore 4 and the transfer result was successful. So this is how things work. So producer will keep on producing the messages until we have the consumers available, so that we don't keep on so it's like simulating a scenario where we don't keep on producing the messages if there are no consumers available, so that will unnecessarily pile up the messages in the queue itself. So once those consumers are available, will start producing, it will start producing the messages again. So this was one of the examples for using the transfer queue. So let's move to the next one. So let's close it. So I'll just comment it out and uncomment the second example, which is the drain consumer example. So in this case also we have the same producer, producer 2, sorry, the different producer which I've coded, and so it also has a name associated with it, and so it also refers to the same link transfer queue, and so it also goes into an infinite loop where it starts producing the test messages, and so it puts the message on the queue. And so offer, in this example we are using offer method, which is also a method which is used to put the message onto the queue, and it keeps on putting messages onto the queue, and with every put it goes into a sleep just to demonstrate the delay in producing the messages. So it will go into a 1 second sleep after every after every put into the message. then so we start this thread, and then we have a drain consumer which I have coded. So this is also a runnable, it also implements runnable interface. It has a name associated with it, and it also refers to the same link transfer queue. And so what we do is it goes into the infinite loop, and it first we put it into a sleep of 5 seconds. So during this time period, I think the producer 2 will be producing the different messages, and so then just this is just for demonstration purpose. So then we try to drain all the messages from the queue. Draining means that it tries to get the messages, all the messages which are there, which are present in the queue at that particular moment. So all the messages, it will be all the messages will be read from the queue, and that will be fed into this linked list. Sorry, the array list, and so all the messages will be read, and we can see that how many number of messages which were read, and we can print all those messages. And there is a different implementation as well for this drain to queue, drain to method, wherein we can also specify the number of messages which we want to read. So I'll demonstrate this as well. First, let's run this function, run this consumer and producer method, and see what happens. So if you see here, it producer is producing the messages, and suddenly in between you will see the messages being drained and are being read out of that queue. So I'll stop it. So if you see in the logs, it keeps on putting messages onto the queue. Test message 1, 2, 3, 4, with a sleep of 1 second in between, and 5, and then your drain consumer comes in, and after 5 seconds the number of messages which were read were 5. So it prints all those messages and then goes into the sleep of 5 seconds. Then in meanwhile, producer 2 will be producing messages. So test message 6, 7, 8, 9, 10, and then the drain consumer comes in and drains all the messages. So this time also it will read 5 messages and it will print those messages. So let's try to run the different implementation of this drain 2, wherein we can specify the number of messages which we want to drain in a particular call to this drain to message, drain to method. So let's comment this out, and I'll uncomment this. Let's run it again. So producer is producing the message, but this time if you see the messages which were read were only 2, not all the messages from the same queue. So this is how the drain to message works, drain to method works, and there are 2 implementations to it, wherein we'll be draining all the messages, or sorry, all the messages which are there in that queue, or only the number of messages which we have specified as the argument to that particular method, to the drain to method. So this was it from this video. I'll be sharing this code and the PPT which I was going through in the description box, so you can go through it, and let me know if you have any suggestions, or if you have any queries related to it in the comment section. So this was it from today's video. So I'll be sharing a new video soon. So till then,